All right, let's say you have a fraction like this, like example 1.5, where you have a fraction and there's a square root also in that fraction, so you can rationalize it by multiply it with its conjugate. Okay, so for example, like this case, we do have like t squared plus 9 square root of it minus 3, so what we can do, we can multiply with its conjugate, t squared plus 9 squared plus 3, and just opposite sign of that, as shown in here, as shown in here, right? So you multiply with its conjugate. So when you multiply with its conjugate, the square root will be, removed, so you will get this part, If you don't believe it, you can multiply it one by one, like t squared plus 9 square root multiply with t squared plus 9 plus 3, you can multiply it. So this one you multiply, you will remove the square root, and then you have plus 3 t squared plus 9 minus 3 t squared plus 9 negative 3 multiply with negative 3, you get negative 9. So this one, 3 minus 3, you can remove it and then leave it with this, t squared plus 9 minus 9, so this one, 9 minus 9 is 0, all right? So it become t squared, t squared here. Okay, so that's why you get t squared at the top part. By the bottom part, you will get t squared multiply with t squared plus 9 plus 3, sorry, the square root is until here, you'll get this one. So this one can be simplified, it become 1, so that's why you get this one, so t approaching 0, so this one you can replace with 0. 0 plus 9 is 9. Square root of 9 is 3. Plus 3, you get 1/6. All right. Okay, let's look at the other example, where you have um the fraction as well, and there's a square root. Okay, this one is quite easy. It's actually I transform it to x because it's x, so this is x squared minus 2, so you will get back x minus 4, because square root of x power of 2, you will get x, and negative 2 power of 2, you get 4, so you will have the limit x approaching 4, x approaching 4, square root of x minus 2, and then divided by x minus 4 here, so this one I transform it in this format, and from here is actually this is also the concept of a squared minus b squared, so this is equivalent to a plus b, a minus b, right? So this one, that's why you can expand like this, so when you expand like this is multiplication, so you can simplify it, so that therefore it become 1 divided by square root x plus 2, so square root of x approaching 4, you get 2, 2 here, 2 plus 2, you get 1/4, all right. Similarly, for this case, okay, now we have a fraction, you can do rationalization, but then again, at the top part also, you got square root. At the denominator part, which is the bottom part, also you get square root, so you can do multiple conjugate rationalization, first you multiply with the bottom part first, so the bottom part first, you multiply with its conjugate, and then you multiply with the top part, so you will leave it with this, so you can simplify x minus 2, x minus 2 here, and now you replace x approaching 2, x approaching 2 plus 2, you got 4, square root of 4 here, this one is square root of 9, so therefore you get 3 plus 3 6, 2 plus 2 you get 4, or you simplify it become 2/3, all right, what if we have a limit for trigonometric fraction? So now, just now is a fraction. We see the linear, we see the polynomial, the fraction just now, and now we look into the trigonometric function. All right, we can replace the limit problem with another form that may be simpler to solve. So L'Hopital rule, this one, this is the name of the mathematician who proposed this rule. Tell us that if we have the interdeterminate that is form of the fraction 0 divided by 0, 0 divided by 0 is undefined, infinity divided by infinity, so we cannot use rationalization in this case. So what we can do, we can differentiate the numerator. We can differentiate the numerator and differentiate the denominator, so we can take the limit. So if as is the case where if you translate, sorry, you transform the function of fx and you transform the function of gx and you divide it, you get like 0 over 0, or you get infinity divided by the infinity. This is undefined. Therefore, using L'Hopital rule, what you can do, you can take differentiation of that function first, then only you put it in the limit. Okay. For example, let's evaluate sine theta over theta here. We can see that, okay, if you remember, sine theta format is like this. At the 0 is 0 and so on. So this is sine theta, this is theta. So here is pi to pi and so on. All right. So we can see that as theta approaching 0, theta approaching 0. This is 0, Either from left or right, you will get 0. So here will be 0. Sine theta, if theta approaching 0, you will get equivalent to 0. So the top part will be 0, and the bottom part is theta divided by 0. So you get the undefined function. So therefore, you can differentiate both part, the numerator and also denominator. So sine theta, you differentiate it, you will get cos. I hope you still remember trigonometric function. If you differentiate sine, you will get cos. If you differentiate theta over d theta, you get 1. So cos theta is 1 because cos is like this. Like this. Cos is like this. I hope you still remember. This is 1. So as the theta approaching 0 from the left and right, you will approach the number of 1. So 1 divided by 1, the answer is 1. So the limit of this function is equivalent to 1. All right, let's look at example 1.8 for this. So you have the L'Hopital rule as well, sine 3x. So x approaching 0, so you will get sine 0 divided by 0. So you will get 0 over 0. This part you will get 0, this part also you will get 0. So due to that, you can what do you call, use L'Hopital rule where you can differentiate the numerator part and denominator part. So differentiate sine 3x, you will get 3 cos 3x. Differentiate 4x, you will get 4. So cos 3 multiply 3, cos 3 multiply 0. So this one will be 3 cos 0. Cos 0 will give the value of 1. Therefore, 3 divided by 4. All right. So in a way, uh, if let's say, we have the function of, where is it just now? This one, So if we have the limit of sine theta divided by theta, and theta is approaching 0, the answer will be 1 as shown in this example. The same goes to like limit theta divided by sine theta. So you take if for this case, limit theta divided by sine theta, theta approaching 0. So if you replace directly, you will get 0 over 0. So we can use L'Hopital rule. What we can do, we can differentiate this one. You get 1. Sine theta, you get cos theta. And theta approaching 0. So cos 0 would be 1. 1 divided by 1 and equivalent to 1. Therefore, we can say that if you have the function, a fraction like this, sine theta divided by theta is equal, and then the limit is theta approaching 0, you get equivalent to 1. And any function, cos x, as x approaching to 0, you will get 1. All right, for this example is x cot 2x. Cot, we can translate cot into cos over sine. So it become like this, and cot 2x divided by sine 2x. What we gonna do is, okay, we multiply with 2 divided by 2. This is equivalent to 1. There's no problem. We just want to make sure that it looks like sine divided by, I mean we want to make sure that it looks like this. So here you will get 2x cos 2x sine 2x. So here, limit x approaching 0. For this part, this is actually this format. All right. So it looks like this. This part, it looks like this format, which is equivalent to 1. Okay. Therefore, you can translate it. Hold on, I think you cannot see from here. Let me rewrite once again. Okay. Let me rephrase this one. I'm afraid you get confused. Eh, sorry. So now, from here, this format, I transform to here. I multiply 2 divided by 2, which is I multiply with 1 actually. So when we multiply here, you will get the limit x approaching 0, 2x cos 2x, 2 sine 2x. So I want to make sure that it looks like this. So hold on. So this part I separate it. It become limit x approaching 0, 2x divided by sine 2x, and then 1 over 2 cos 2x. Because you left with this part, you left with this part. That's why I separate it like this. So this part, hold on. This part this part already look like this. So this is become 1. Eh, eh, eh. How? Oh, this one become 1. And then cos 2x, x approaching 0, you will get 1. Therefore, the answer is half. Okay. All right. I continue 1.15 in the next video together with 1.16. Okay.